viewers. This is Ademola Johnson, your science tutor. Please share this video, like it. Go to my YouTube channel titled Ademola Johnson and subscribe and have access to information. Because if you lack information, you are deformed. If you are not informed, you are deformed. Knowledge is power. Take note. We have started talking in chemistry, talking about laws guiding electronic configuration. We have talked about Heisenberg's uncertainty. We have talked about Aufbau's principle. Now we want to talk about Hund's rule of maximum multiplicity, after which we are going to talk about Pauli exclusion's principle. Now let's look at Hund's rule of maximum multiplicity. What did this law state? This rule states that while filling orbitals of the same subshell with electrons, while filling orbitals of the same subshell with electrons, electrons are first singly filled before pairing occurs. Hund's rule of maximum multiplicity says that while filling orbitals of the same subshell with electrons, electrons are first singly filled before pairing occurs. What do we mean by orbitals of the same subshell? We are talking about the degenerate orbitals like px, py, pz. They are the orbitals of the same subshell of what type of orbital? Of p orbital. Now, d orbital has how many? 5 orbitals of the same subshell, while f orbital has 7 orbitals of the same subshell. As we continue, you begin to see what I'm saying. Now, let's look at this table. Serial number. Then we have name and symbol of elements. Then next is what? Electronic configuration in boxes. Now let's talk about the first one. Is hydrogen. Hydrogen, and the symbol of hydrogen is H. Hydrogen is the number 1. That's only 1 electron. Now 1s1, and there's a box. In this box, we are representing electrons with half arrow. Mind you, not full arrow. I've seen some textbooks that they will be putting full arrow like this. It's wrong. Like essential chemistry. It's very wrong. Because this half arrow means a spine quantum number. 1 over plus or minus 1 over 2. That is the direction of, when you get to quantum number, you understand what I'm talking about here. Half 1 over 2 means that it is spine quantum number. Half arrow, not a full arrow. Mind you, a half arrow. This arrow now, the one we are beginning with, is going up. Then the second one is helium. Helium He. This one is 1s2. Then we have 1 arrow up, 1 arrow down. 1 arrow up for the first electron, 1 arrow down for the second electron. Why it is so, we are going to talk about that in Pauli exclusion's principle. Number 3 is lithium. Lithium Li. And don't forget that lithium is 1s2, 2s1. So now, whose rule does not affect s orbital? It starts affecting p orbitals. So number 4, beryllium. Beryllium Be. So we have 1s2, 2s2. So this, for these two, half arrow up, half arrow down, half arrow up, half arrow down. So that is that. Now let's continue to serial number, the name. Okay. Number 5 now. Boron. Boron B. So boron is 1s2, 2s2, 2p1. Yes, you have got to where we are talking about now. So for these two electrons that is here, one electron goes up, the other one comes down. One goes up, the other one comes down. Now this p orbital. Don't forget, in our previous video, p orbital has 3 degenerates: px, py, and pz. But this ps, py, and pz now, they are orbitals of the same subshell. What is the name of that subshell? P orbital. So, and the rule says, while filling orbitals of the same subshell with electrons, electrons are first singly filled. So, if first of all start from the first box. I've seen some question before, see jump, they write something like this, they write something like this, they write something like this. They now say, okay, they now say, mention 2 rules that are disobeyed with this. Number 1 rule disobeyed is half-bound. This one is not filled. This one is not filled. Then now coming to fill this one. This is 2s, 2p. So half-bound says what? While building up an atom, electrons are first filled into orbitals with lower energy level. This one is lower. This one is lower. Before filling orbitals with higher energy. So half-bound principle has been disobeyed. Then another principle that is disobeyed is whose rule? Because if you are to fill singly first, you have to start from this first box. So if they say state 2 rules disobeyed here, half-bound principle and whose rule of maximum multiplicity. Now number 6 is carbon. Carbon C. So we have 1s2, we have 2s2, and we have 2p2. Now look at it now. These ones don't have business with whose rule. Don't have business with whose rule. Now where the business are now, there are 2 electrons and there are 3 spaces. Fill singly first. Fill singly. So number 7 is nitrogen. Nitrogen is 1s2, 2s2, 2p3. For these two, I put 1 half arrow up, 1 half arrow down, 1 half arrow up and down. Here now, singly. First of all, put 1 here, put 1 here, put 1 here. Then after that is oxygen. Oxygen O. So we have 1s2, we have 2s2, we have 2p3, 2p4. So So this one have no business with Hund's rule. Put it to them. We want to put 4 inside orbitals of the same subshell. Fit singly first. 1, 2, 3. You now remain 1. Then before pairing will now take place. Before fit singly, then when everywhere is fit, then you now start pairing. Pairing means putting 2 together. So then that is that. So we move on to the next one, which is fluorine. Fluorine F. So this one is 1s2, 2s2, 2p5. Put 1 here, 1 up, 1 down, then 5 into 3 boxes. Fill singly first. 1, 2, 3, 4, 5. Fill singly before pairing. That is outbound. That is summary. Fill singly before pairing. Okay? Number 10. Number 10. That's neon. Neon Ne. That's 1s2, 2s2, 2p6. So 1 is here, 1 is here, 1 is here, 1 is here. Now 6. Fill singly first. 1, 2, 3, then 4, 5, 6. Fill singly before pairing. Now we are moving to the next one, number 11. Let me shift the box here to have enough space. So number 11 is sodium. Sodium Na. So we have 1s2, 2s2, 2p6, 3s1. So we put 2 here, 1, 2. Then fill singly first. 1, 2, 3. Then 4, 5, 6. Then here is only 1 electron that's there. So next one is magnesium. Number 12 is magnesium. Magnesium Mg. So this is 1s2, 2s2, 2p6, 3s2. So I have this one. Fill singly before pairing. Then this one has 1, 2. So we are moving. Now we are now going to aluminium. That's number 13. Aluminium. Al. So this one is 1s2, 2s2, 2p6, 3s2, 2 Then after 3s, we have, don't forget to have K, 1s, L, 2s, 2p, then M, 3s, 3p, 3d. Then you now have N, which is 4s. So we have that this is 1s, 2s, 3p. After 2p is 3s. After 3s is 3p. So now, see what we are doing here. Put 2 electrons here. 1, 2. One, 2. 2 electrons here. 1, 2. Now 6 electrons. Fill singly. 1, 2. Before pairing. 6. Then this one has 2 electrons. 1, 2. Now this is what? 3p is only one that is available. So we'll put the one here. Fill singly first before you pair. Don't forget that. Next one is 13. Is number 14. Silicon. Silicon Si. Silicon Si is 1s2, 2s2, 2p6, 3s2, 3p2. Now, for these 2 electrons, we have 1, 2, 1, 2. Fill singly 1, 2, 3, 4, 5, 6. 1, 2. Singly, there are 2 here. 1 and 2. Finish. So that is silicon. So we move to phosphorus. Number 15. Number 15. That's phosphorus. Phosphorus P. So we have 1s2. Let me take care of this, please. Now we have 1s2, 2s2, 2p6, 3s2, 3p what? 3. So we have 1 electron, 1 up and down. 6, 1, 2, 3, 4, 5, 6. Fill singly before pairing. 1, 2. Here also 1, 2, 3. Fill singly first before you start pairing. So next one is number 16. That's sulfur. Sulfur S. So this one is going to be 1s2, 2s2, 2p6, 3s2, 3p4. So I have 1 electron, 1, 2 for these 2. 1, 2, 3, 4, 5, 6. Then here I have 1, 2. Here 4 electrons, so I have to put 1, 2, fill singly first before pairing. So you have that. 17 now. Number 17. That's chlorine. That's chlorine. So So 17 now is chlorine. Chlorine Cl. And there I have one S2. I have two S2. I have 2P6. 3S2. 3P what? The last one was 3P4. It's now going to be 3P5. So I have one electron, 2, 3, 4, 5, 1, then pair, 1, 2. So 5 electrons, you have 1, 2, 3, 4, and 5. Fish singly before pairing occurs. Then number 18. Number 18 is argon. Argon AR, sorry. So this one is going to be 1S2, 2S2, 2P6, 3S2, 3P watts, 3P6. So I put 2 electrons here, fill singly 1, 2, 3, 4, 5, 6. Then 1, 2, then 6, 1, fill singly first, 3, 4, 5, and 6. And it's fully occupied. Fully occupied. So the next one is number 19. Can you start it before I write on the board? Number 19 is potassium. We are still going to 30, we are still on 19. So potassium, that's number 19. Number 19 is potassium. Potassium K. And the configuration is 1S2, 2S2, 2P6, 3S2, 3P6, 4S2. Don't forget, the 4D is missing because it doesn't carry electron. So we have 1, 2, 1, 2, fill singly 1, 2, 3, pair 4, 5, 6, 1, 2, fill singly 1, 2, 3, and you have 6, 4, 5, 6. Then only 2 electrons, one electron is here. That's here. So number 20 is calcium. Number 20, that's calcium. Calcium Ca. So what do I have here? I have 1S2, 2s2, 2p6, 3s2, 3p6, and 4s2. So put two electrons here, 1, 2, 1, 2, 1, 2, 3. Then pair 4, 5, 6. 1, 2, singly 1, 2, 3. Pair 4, 5, 6. Then we have two electrons, 1 and 2. So the next one is scandium. Scandium. That's number 21. Number 21 is scandium. Now, I want us, please, you can copy what you want to copy now because I want to wipe the board. I need a wider space for the next 10 elements. Can I clearly take the board now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The board is gone. All right. So next one is 21. That's scandium. Scandium Sc. The configuration is 1s2, 2s2, 2p6, 3s2, 3p6. Then we have 3d first. 3d 1 before we now have 4s. 4s2. And 3d has how many? 5. 1, 2, 3. 1, 2, 3, 4, 5 boxes. So this one now, put 1 here, 1 here, 1 here, 1 here. 6. 1, 2, 3. Pair 4, 5, 6. Singly 1, pair 2. 6. Singly 1, 2, 3. Pair 4, 5, 6. Yes. Then this one is feed first. It's only copper and chromium that has 1 there. Then out of 5 boxes, you want to put 1 here. So put feed singly first. Let this one take it. Now, number 22. Titanium. Titanium Ti. Now, titanium Ti. We have 1s2. We have 2s2. We have 2p6. We have 3s2. Then we have 3p6. We have 3d. We have 3d. Then you have 1, 2, 3, 4. You have 3d2, 4s2. So put 2 electrons here. 1, 2, 1, 2. Singly 1, 2, 3, 4, 5, 6. 1, 2. then singly first, 1, 2, 3, then pair 4, 5, 6. Now this one, put here 1, 2. Then here, 2 electrons occupy 5 boxes. Put one here, 1 and 2, and it's okay. So the next one is going to be vanadium. Vanadium. That's 23. Vanadium. Vanadium V. So it's just to change this into 2 and put one more here. So the next one is 24. Chromium. Chromium Cr. It's just to change this one. You know chromium, okay. Let's come back here. Instead of chromium and copper are 4s1 and double fit. This one supposed to be, since this one is 2, this one supposed to be 3. Okay. Vanadium is we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay. Okay. So I think we have done titanium. So for vanadium, it's supposed to be 3. 3. That's making it what? Making it, yes. Then chromium, supposed to be, after this 4s1, then it's supposed to be, it should not be 3d5 instead of 3d4 before. Then for 5, now 1 year, 1 year, 1 year, 1 year, and 1 year. Mind you, this is what? That. Then the next one is number 25, which is manganese. 25, which is 25, is manganese. Manganese Mn. So manganese, we just have to add what? We have this one that will have the 5, then 4s2. So then the 2. So the difference between manganese and chromium has one filled box here, and 5 3D. This one also has 5 3D, but 4s is filled with 2 electrons. So then number 26 is iron. 26 is iron. Iron Fe. So we are going to just add, this is returning this one to what? To 2, and 3D what? 6. If 3D is 6, just come and pair this place. That's all. So fit singly, then pair. Then number 27. 27. That's a cobalt. Cobalt CO. So it's just to put what here? 7. 3d7. So if it is going to be 7, fit singly 1, 2, 3, 4, 5, then 6, 7 before pairing occurs. The next one is nickel. 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 Nickel Ni. So this one is going to be 7 is here. Then, so if it is 7, fit singly, this 1, 1, 2, 3, 4, 5, 5, then 6, 7. Fit singly before pairing occurs. Then Another bastard apart from chromium is copper. 29. Copper. Copper, Cu. So this one is going to be, it's going to first of all end in 4s1 and 3d10. It's supposed to be 3d9. But since it's now 4s1, it's adding 1 to this. So then, if we have 10, this is going to be 1 electron that will be here. So, for nickel, it was supposed to be 2 here. Please take notes. It's supposed to be 2 arrows, 1 up and down. So this is this. Then for it to be 10, fill singly first. Singly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is that. Then lastly, I have zinc, number 30. Zinc, Zn. So this one is going to be 4s2, 3d10. So all this will be filled to capacity. So I think we are done with this lecture. This is the application of Hund's rule of maximum multiplicity that states that while filling orbitals of the same subshell with electrons, electrons are first singly filled before pairing occurs. If you have any question, put it in the comment section. Let's discuss it. And if you want to talk to me, click the WhatsApp button in the Facebook. And if you are without the you have 770 30 39 35 31 is my WhatsApp and my phone number. You can talk to me, ask me question, then God will help us to answer appropriately. Please share this video, like it, subscribe to my YouTube channel titled Afe Ademola Johnson. See you at the top. God bless you and bye for now. Thank you.